Okay, so slope fields that represent the differential equation. This one, oh no, pressed all the buttons. Okay, so what we're really going to look for first is some telltale signs. So we can see here that when y is equal to 0, wrong pen, y equals 0, our function will be undefined. And we know that when x is equal to 0, that means the numerator here will be 0. So it doesn't matter what happens on the bottom, so that will always have a slope of 0. Okay, so when x is equal to 0, it should be straight lines going the whole way across. So this is a possibility, this is a possibility, this one is not, and this one is not. Okay, the next thing that we're going to be looking for is we're just going to pick a point and determine which one is true. So if I pick a point in here when x equals -1 and when y equals -1, if it's this one here, I'll end up with a positive gradient. If it's this one here, I'll end up with a negative gradient. So let's go ahead and substitute those in. dy over dx is equal to -1 over 2 times -1 is equal to -1 over -2, meaning that it's just positive a half. So this one here is the positive gradient. So our answer is going to be D. Now question 7. Which of the following best describes an interval estimate of a population parameter? So the first one, the degree of uncertainty associated with the interval, but that doesn't have a lot to do with the population parameter. The easiest way to start this question is to go and Google interval estimate of a population parameter. So an interval estimate is defined by two numbers between which a population parameter is said to lie. So it's saying that for our interval estimate, the population parameter should be between those two numbers. So let's go back again and have a look at these. So the proportion of values, it's not really about the proportion. An interval that is calculated using the population parameter, well, kind of, but not really, because the population parameter should be between your two answers, meaning that D is our answer. So an interval that is likely to include an unknown value of the population parameter. That's our answer.